This is video for day 7, and it's number 3. There's mixed practice with special right triangles here. Just a couple of other examples where the special right triangles show up. For question number 1, they've given me a picture, and in this picture there are 3 different triangles. There's the big triangle, which is a 45, 45, 90. And if I'm focusing on that big triangle, I'll kind of draw it over here. In a 45, 45, 90, if this is 6 across from the 45, then this is 6 across from the 45, which means that this side down here of y is my a radical 2 side, which is 6 radical 2. So y turns out to be 6 radical 2. Then I'm going to focus on this triangle. So I'm shifting my focus now. And this is a 45, 45, 90 also. And they're telling me that this side is 6. That's the information I gathered from the first part of this problem. If that's 6, that is the side that's the a radical 2 side. So I need to divide by radical 2 on both sides. And I get a is equal to 6 divided by radical 2, and then I multiply by radical 2, which ends up being that this side of x that's right here, which is really the a side, is 3 radical 2. This is also, but that's not what they were asking us for. So you kind of have to shift which triangles it is that you're looking at. If I am looking at example number 2, the first thing I'm going to do is focus on this triangle that's here, and in that triangle they're telling me that this side here, which is across from the 90, is the a radical 2 side, which is 5 radical 2. And in here, if this is 5 radical 2, that's the a radical 2 side, which means that 5 must be equal to a. And this is my side of a that's here. This is also a, so this is 5. In this case, this triangle that's kind of the one at the top of the picture is also a 45, 45, 90 triangle. So I know that these angles are 45. This angle was 45, and so was this one. And in this particular case, I'm being asked to find y. Remember, this side right here is 5 radical 2. So in my triangle, if this is 5 radical 2, across from the 45 degree angle, then across from the 90 is a radical 2. My a value is 5 radical 2, so it's 5 radical 2 times radical 2, which will give me 10. So this side of y that's here is really 10. Questions 3 and 4 do not have a picture drawn. It's your job to draw that. And question 3, it's talking about the altitude of an isosceles triangle if its vertex angle is 120. So this angle up here is 120. The altitude that's drawn in goes here, forming a 90 degree angle at the bottom. By definition, that's what an altitude does. The legs are both 8. The altitude that's drawn into an isosceles triangle from the vertex angle to the base is not just an altitude, it's actually also a median, and it's also an angle bisector. So that means that that 120 gets split. If I figure out the missing degrees that I have over here for that triangle, that's going to be 30. So right now I'm going to focus my attention on this triangle. I've got my 90 degree angle, which is across from at the 2a side, which means that a is really 4. A goes across from the 30, which means that this altitude, which is what they were looking for, will be 4. For question 4, we have an isosceles triangle with a base angle of 45. If one of the base angles is 45, we know the other one must be 2. Base angles of an isosceles triangle are congruent. which leaves me 90 degrees for the top vertex angle. It's telling me that one of the legs of this triangle is 5 radical 2. That's my side of A. They want to know what the altitude is, so if I drop an altitude in here, I am technically creating another 45, 45, 90 right triangle, which means if I look at now just this triangle, this side is no longer the A side, but it is the A radical 2 side because it's across from the 90-degree angle, which therefore means if 5 radical 2 is equal to A radical 2, A is 5, and the altitude, which was this, is your side of A, as is this one, which means that in this case your altitude is equal to that A value of 5. For question 5, they're asking you to determine the exact area of the shaded region below. To figure out the area of this shaded region, I am going to focus on the rectangle that shaded region occurs in, which is this rectangle. I'm going to figure out the area of that, and I am going to subtract away the quarter of the circle that you see here and the quarter of the circle that you see here. So I have 2 quarter circles. Technically, if I figure out the area of one of the quarter circles, the other one will be the same. So I'm going to say that I'm going to find the area of the rectangle minus 2 quarter circles, which is a half of a circle, because they're the same. So in here, the shaded is equal to the rectangle minus the half circle. So in here, my job is to figure out the length and width of the rectangle. If I take a look and focus just on this right triangle right here, in that right triangle, I know that these 2 sides have to be the same because they are both radii of the circle, as are these 2. So all of those measurements are the same. If I just focus on this right triangle right here, this side of 10 is my A radical 2 side. It's across from the 90. These sides are both A, as is this one and as is this one. So when I go through and solve for A, I get 10 divided by radical 2, and then I'm going to multiply both by radical 2. So I end up getting that A is equal to 10 radical 2 over 2, which is 5 radical 2. So therefore, this is 5 radical 2, this is 5 radical 2. These are radii of the same circles, so they're 5 radical 2. And then this measurement here is the same as this length here, which is 5 radical 2 plus 5 radical 2, which is 10 radical 2. So by finding that A value, we were able to figure out all of the dimensions that we need. For our rectangle, the dimensions are 10 radical 2 and 5 radical 2, and I'm doing area, so base times height. So 5 radical 2 times 10 radical 2 minus half the area of a circle, and the area of a circle is pi r squared. The r value is the radius, and it doesn't matter which radius you look at, any of them, they're all A, which is 5 radical 2. So when I go through and calculate this, I multiply these 2 together for the area of the rectangle, which gives me 50 times 2. Multiply what I can here together, and when I multiply together what I can, I end up with 5 radical 2 over 2 pi. I'm multiplying fractions. Final answer then, 100 minus 5 radical 2 over 2 pi. I know that this is my final answer because the directions say exact area. Exact area means that if you have a pi or a radical in your question, then you want to leave that as your final answer. Do not round any of the decimals. Keep it exactly as you see it with a radical and a pi both in that answer.